Well, the question is Cambridge, comes from Cambridge Assessment International Education. That is advanced subsidiary and advanced level. And the paper is paper 6, probability and statistics 1, that is S1. The code is 9709/62, which was taken May/June 2019. Our question of interest is a continuation of our series as we consider discrete random variables, which is a topic in paper 6 of this particular exam. So that question was tested in question 5, and it reads, Mariam has 7 sweets in a tin. 6 are toffees and 1 is a chocolate. She chooses 1 sweet at random and takes it out. Her friend adds 3 chocolates to the tin. Then Mariam takes another sweet at random out of the tin. Draw a fully labeled tree diagram to illustrate this situation. Now, this means that Mariam first picks a sweet. After picking a sweet, then a friend introduces 3 more chocolates. But initially there was only 1 chocolate. But now, if she picked 1, then it should mean that it is possible that she picked a chocolate or she picked a toffee. So let's see. Draw a fully labeled diagram, a labeled tree diagram to illustrate this situation. 3 marks. And 2. Draw up the probability distribution table for the number of toffees taken. Yeah. Then Roman 3. Find the mean number of toffees taken. 1 mark. Then find the probability that the first sweet taken is a chocolate, given that the second sweet taken is a toffee. 4 marks. So that's the question that we want to look at today. Let's see the solution. Now, we are told that Mariam has 7 sweets in a tin. 6 are toffees and 1 is a chocolate. She chooses 1 sweet at random and takes it out. Her friend adds 3 chocolates to the tin. Then Mariam takes another sweet at random out of the tin. Draw a fully labeled tree diagram to illustrate this situation. So first, this is how our tree starts. Our tree begins as such, where there are only 2 options, toffee or chocolate. But because Mariam does 2 pickings, then this is first picking, the second picking will go as such. Again, it's toffee, chocolate. The second picking, toffee, chocolate. That's what we have. So we need to put the probabilities. So we are told that Mariam, okay, she chooses 1 sweet at random. So by the time she's choosing 1 sweet at random, there are 7 sweets in. So in that case, the first probability we have, how many toffees are there? There are 6. So it's 6 out of 7. How many chocolates are there? It's 1 out of 7. So this plus this should give us 1. That should give us 1. So that's in the first picking. But realize that after this picking, the friend adds, her friend adds 3 chocolates to the tin. So after the first picking, what was left should be 6. So if at all what was picked is chocolate, if what was picked here, the first picking was chocolate with a probability of 1 over 7, then probability of picking another chocolate will be 3 out of 9. Will be 3 out of 9. Why? It will be 3 out of 9 because after picking the first one, all that is left in the tin are 6 sweets, but there was only 1 chocolate. So if there were 7 initially, but 1 has been picked, then it means, and that 1 is chocolate, it means that there are 6 sweets left and there is no chocolate left. But then the friend adds another 3 to the 6 sweets which are left, which are not chocolate. So there are 3 chocolates and 6 toffees. So the chance of now picking another chocolate in the next picking will now be 3 over 9. And if this is 3 over 9, this is straight away 6 over 9. Now, let's consider a situation where the first picking was a toffee. So he picked up a toffee with a probability of 6 over 7. So it means there are 5 toffees left. So this will be 5 over 9 because now the total number of sweets is 9. So this is 5 over 9. And so this is 4 over 9. Now, that's the tree diagram. That's the tree diagram of that scenario. So those are the probabilities. Realize that this plus this is 1, this plus this is 1, this plus this is 1. If you were to get the probability of T and T and add them here, add what you get here, 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 and here, that will still give you 1. But we'll get there if at all the question requires us to. Now, that's the tree diagram. So that's Roman 1. Fully labeled should just mean, I think that's just that. Then draw up the probability distribution table for the number of toffees taken. Now the number of toffees taken, probability table for the number of toffees taken. So let me say, let X represent the number of toffees. Okay, let it be T. Doesn't have to be X all the time. Represent the number of toffees. Then probability that is picked will be, so it is because there are 2 pickings, it is possible that in that first picking, Mariam picks no toffee, in which case there'll be 0, or picks 1. Just a moment. It is possible, because there were 2 pickings, it is possible that the first time Marianne picked a chocolate, and in the second picking, she also picked a chocolate, in which case there is no toffee. In which case there is no toffee. Or it's possible that in the 2 pickings, one of them is toffee, in which case she may have started with toffee, then coffee, then chocolate, or chocolate, then toffee. But it's 1 anyway. Or it is possible that in the 2 pickings, the first trial she picked a toffee, and in the second trial she also picked a toffee. That's also a possibility. So 2. So those are the only possible values that T can take. So if she picks 0, if she picks no toffee, it means she picked chocolate and chocolate. In which case, what is the probability? Chocolate and chocolate. Picked chocolate, then picked chocolate. So it is 1 over 7 times 3 over 9, which is 3 over 63. 3 over 63. But then there's also possibility of picking 1 toffee. And picking 1 toffee is possible that she picked toffee at first, then picked chocolate, or first picked chocolate, then picked toffee, in which case she's got 1, 1. So it's this or this. So here I'll be having 6 over 7 times, this is 24 over 63. This is 24 over 63. And then what do I have here? CT, this is 6 over 63. 6 over 63. So add this to this. It's 30 over 63. So here I have 30 over 63. 30 over 63. That she picked 2 toffees. That means she picked toffee and again picked toffee. So that is 30 over 63 again. That is 30 over 63. Now that's our probability distribution table. And if you add all this, they should give you 1. So that's that. Then Find the mean number of toffees taken. Mean number of toffees taken, mean number of toffees taken will then be expected value of x is equal to 0 times 3 over 63 plus 30 over 63 plus 60 over 63. And so we have there 63. This is already 0. And that's 60. 63, that's 90. So we have 90 over 63. Expected value of x will be 90 over 63. So 90 over 63 is approximately, if you work it out, that should be approximately 1.43. And that's the expected value of x. What else are we asked to find? Find the probability that the first sweet taken is a chocolate, given that the second sweet taken is a toffee. Right. Yeah, that's interesting. So let A be the probability first is chocolate, and B be the probability that second is a toffee. Then we remember the the bias. Here we remember the bias theorem. And it's what is we had used it. It's used for conditioning probability. It's a form of conditional probability, because this is conditioning. So then probability that A given B is given by probability of A and B over probability of B. That's what we should have. But then, what is probability of A and B? Probability of A and B simply means that first is chocolate and second is toffee. First is chocolate, second is toffee. First chocolate, second is toffee. So this is this, which is 6 over 63. That is 6 over 63. 6 over 63. Divided by probability that second is a toffee. Probability that second is a toffee. So second can be a toffee here or here. So I need to add this to that. So if this gives me 6 over 63, but then this gives me now 30 over 63. This should give me 30 over 63. So 30 over 63 plus 6 over 63 is 36 over 63. So divide by 36 over 63. And that means that probability of A given B, as we want, is 6 over 63 times 63 over 36, which is 1 over 6. So 1 over 6 is the probability that the first sweet taken is a chocolate, given that the second sweet taken is a toffee. That is the solution to that part. And up to there, we meet in my next video.